Today we are starting on our last chapter. We are into chapter 11, which is all about motivation and emotion. And this is a pretty varied chapter. Motivation and emotion don't necessarily connect super well, but we're going to do our best to bridge the gap. And there's a couple of different examples. We can talk about motivation in terms of weight and hunger regulation, which is the part of the chapter that I choose to focus on. There's also some sections on motivation in terms of achievement. There's even an interesting section on sexual motivation. And so as per usual, we're going to start off with our definition, and motivation is specifically a process that's influencing our goal-directed behavior. And so if it's goal-directed, you're trying to accomplish something. And so we can talk about the direction of this motivation. Is it encouraging you to do something more or to do something less? How is it influencing your persistence? Do you keep going on something? Are you going to stop? How motivated are you? Or is it something you're going to be motivated to persist on for long periods of time? Or is it short-term motivation? And vigor, so how vigorous is this motivation? Is it something that's really powerful and driving and it's pushing you towards something intense? Or are you just moderately motivated? Like maybe you'll wander to the fridge later on. So all of these things can describe our degree of motivation. And the first part of today's lecture, we're going to bring back some of the old ideas and concepts, stuff that we've built up throughout this whole course. We're going to talk about some of the views of motivation and specifically get into some theories and perspectives on how motivation might be working. And so this is going to be a lot of review for some of the earlier stuff that we've talked about, but bringing back a lot of things that have kind of come up at least in some degree. So we're going to talk about instinct theory and how that's related to evolutionary psychology. Talk about homeostasis and drive theory. Incentive and expectancy theories, which are pretty interesting. And then we'll get into the psychodynamic and humanistic theories. So all of these should have at least some keywords that are familiar. And so we're going to start with our instinct theory and talk about how that gets us towards modern evolutionary psychology and those perspectives. But when we're talking about an instinct, we're specifically talking about an inherited predisposition to behave a certain way in response to certain stimuli. So it's a predictable response to a particular situation. And instinct theory is going to be based rather heavily on Darwin's theory of evolution, bringing it all back together. And the idea being that instinct motivates our behavior. So these predispositions to have a specific behavioral response to a certain situation, that's motivating those behaviors that we're seeing. And if those behaviors are influencing our fitness, our ability to survive, then those instincts can then be acted upon by evolution. And so some of our specifics here are that genetics should be at least partially genetic based. So an instinct isn't something that we've learned. It isn't a learned behavioral response. For this to work at the evolutionary level, an instinct has to be something genetic, at least a predisposition towards behavior to be genetic. But there should be a genetic component for natural selection to act on. It should also be found among all members of a species. So if it's genetic, it should be in the genes of everyone within that population, within reason. It should also be independent of learning. So just like I said at the beginning, we want it genetic based because we don't want it to be something learned from our environment. And if natural selection is going to act on these instincts, they should be somehow related to the survival of the organism, where natural selection will select for instincts that improve survival chances of an organism. And natural selection will act against, will remove instincts that reduce survival of an organism. So they should be something that selection can act upon. And so when people started talking about instinct theory, they started talking about thousands of different possible instincts that could exist in humans. Everything from how we act when we're given food. So you get hungry and you want food, or you enjoy warm spaces for a particular reason. Those could all be instincts because they come from something internal and instinctive. But the theory never really got off the ground. Even though they could propose all of these different types of instincts, people never really bought into this theory because it employed what's called circular reasoning. And so to explain circular reasoning, I found the best way to do it is to use an example. And so we can start with the idea that greed is an instinct. And it's like, okay, so if greed is an instinct, we can then ask the question, how do we know that greed is an instinct? Well, greed is an instinct because people are greedy. We see greed as a human trait, so greed is an instinct. Okay, but why are people greedy? How do we then explain greed? Well, people are greedy because greed is an instinct. And so you never actually get any new information brought into this argument. And so saying that people are greedy because it's instinctive isn't necessarily wrong, but then explaining that we know greed is an instinct because people are greedy, we're not getting any information. We're not approaching this scientifically. And so it's not a good theory if there isn't any way for us to disprove this argument, if there isn't any way for us to measure and quantify the thing that we're talking about. And so, like I said, this instinct theory never really caught on. But a lot of the things that we've talked about, how instincts work, and the fact that they are genetically based and influencing fitness and survival, kind of sounds a lot like what we've talked about within evolutionary psychology. And that brings us to the modern interpretation of instinct theory, or instinct theory 2.0, which is really just a modern evolutionary psychology view of how behaviors can evolve. And so this is going to focus on the psychological motives that exist within populations and the idea that those are based on evolution. So the things motivating our behavior can in turn be acted upon by evolution so that behaviors that improve our survival and fitness are going to become more common in a population. They will become more let me make sure I say this right. They will become more embedded within a population. They're acted upon positively by natural selection so that most of the population will have that trait because it's a good trait in that situation. And so we're looking specifically at the genes that are linked to the behaviors that are then increasing our chances of survival and reproduction. And survival and reproduction is fitness. And so we can talk about this in terms of adaptive significance. And we've talked about adaptations previously in the course, and that's the idea that something is evolutionarily beneficial. It's helping us to survive and reproduce. And so if we're looking at adaptive significance, we're saying how much of an improvement in survival is this particular gene that's giving us a particular behavior? How much of an influence is that giving us? And so things that are more beneficial will become more common in the population a lot faster. And that's sort of the basics of how this theory works now. And of course, you can imagine that there's far more to modern evolutionary psychology, but for our Cole's Notes version in terms of motivations, that's as far as we're going to go. Our next topic is going to be drive theory, which is going to relate directly to homeostasis, which we've already brought up a couple of times throughout this course. So it's coming back again, this time looking at the motivation side of things. And so we should all know by this point that homeostasis is an internal physiological equilibrium that the body strives to maintain. And it's a delicate balance that makes sure that our body is functioning optimally so that we survive as best as we can. And so I've always talked about homeostasis. It's easy to think about it as maintaining body temperature, but there's so many other factors here. It's not just body temperature. It's the pH of your blood. It's the concentration of different sugars in your systems. It's absolutely everything. Everything within our bodies exists at a certain balance point. So if it's easier to think of it in terms of temperature, that's totally fine, but don't forget that it can apply to all sorts of different traits. It's not just temperature, there's other things involved. And so to maintain this homeostasis, the body has to maintain the process. So we can start with our internal state, and we'll use our example of temperature. And so to make sure that we are maintaining our normal body temperature of about 36 degrees Celsius, we are going to have sensors that are going to monitor and detect any changes in that internal state. So our body will notice if our internal temperature gets too hot or too cold because of these sensors. We're then going to have a control center that's going to take that information from our sensors. If neurons in our body have noticed that the body temperature is too hot, then the control center is going to enact some kind of behavior because of that. So if it's picking up that we are too hot, it's going to trigger some kind of response. And that's where the response system comes in. And that's going to act to restore equilibrium. So if we're too hot, then it can tell our body to sweat to evaporate off some of the extra heat and reduce our temperature to get back to normal. And so when our internal state returns to normal, the sensors will pick up that we're back into our equilibrium point. The control center will read that we're back in the normal range, and it can stop that response. And so this can work with pretty much any kind of thing we can think about. So having the right levels of energy in the body. If our energy levels are too low, then the sensors will tell our control center that we need to start breaking stuff down to get more energy to get back to our normal internal state. And we'll talk more about that when we actually get into eating and motivation for food and things like that just a little bit later in the lecture. And so that's homeostasis. Hopefully that's nothing new to any of you so far, but let's bring it into drive theory now. And drive theory is based on the idea that physiological disruptions to our homeostatic equilibrium, to maintaining homeostasis, disruptions to that state will produce things that are called drives. And drives are going to be states of internal tension, and they will motivate our behavior to reduce the tension. So we've already kind of talked about this, where if our internal state is wrong, our temperature is too high, then we're going to have a drive to get that temperature back to normal. So internally, our body could then produce a sweating response to reduce our temperature, but we can also have motivations to behavior to try and reduce that tension as well. So maybe you're too hot and you decide to take off your outer layer. Maybe you have an extra sweater on, so you can take that off and cool down again. And so the idea is that these drives, these disruptions to our homeostasis, push an organism into action. Another example is if you're really thirsty, you might pause this lecture and get up and go get a drink. Being thirsty pushed your behavior to go resolve the problem. You're returning yourself back to your normal homeostatic balance by having gotten a drink. And so now you're going to notice a pattern of how these theories were originally proposed versus how we see them now. And modern drive theory isn't really as popular as people might think. So we got our modern evolutionary psychology as a kind of replacement for our first theory, but modern drive theory ended up having to fill a very specific niche. And so this idea of homeostasis and internal drives really only works well with a very select grouping of traits. Things like thirst or hunger or body temperature or your weight, sleeping state. Those are things that, yeah, we can make a logical connection to maintaining that homeostatic balance. But there are so many other things that can be going on that motivate us to do something that have nothing to do with our internal state. So our modern drive theory has a very limited scope. And so it's a much less influential theory than some of the other ones we're going to talk about. And in addition to the fact that it only applies to a very narrow range of topics of particular situations, we also have a bunch of examples where even within things that should be explainable by drive theory, we have people who behave contrary to those predictions. And a couple of examples are people watch horror movies. And so when you're watching a horror movie, if you are someone like me who hates being scared, your reaction is going to be an elevated heart rate. Your blood pressure is going to go up. Your breathing's going to get quick. And so you're outside of your homeostatic balance because of this situation. So the obvious way to reduce all of those things to get your body back to equilibrium would be to stop watching the scary movie. But people continue to watch horror movies. They seek out situations that scare them. People go skydiving and all sorts of things that intentionally push them outside of this homeostatic existence. And this theory can't explain why that happens. And we see something similar, and diets are going to be one of those things that is a stickler for a lot of these theories. But if you're hungry, the biological drive is to then go and eat something. But people who are dieting do the exact opposite. So we have problems where very common situations that should be explainable by drive theory don't quite fit within this framework, and so the theory isn't super helpful. So that's all we're going to say about it for now. Next, we're going to talk about incentive and expectancy theories. And these are two separate types of theories that end up working really well together, which is why they go together in this lecture. So first off, for incentive theories, let's define an incentive. It's going to be a thing that motivates or encourages an organism to do something. Something that incentivizes you, that makes you want to do a particular behavior. And so this is going to work as kind of an opposite to what we just saw with drive theory. Whew. So with drive theory, we get a push to do a behavior to fix your homeostatic imbalance. With incentive theory, this incentive, this thing that you want, is going to pull you towards a goal. And so maybe you're motivated by something like getting a good grade. The idea of the potential of getting an A in a class might motivate you to study hard because you want that grade. You're being pulled towards that behavior because you want the outcome. And so this push and pull actually went well with drive theory and incentive theory being considered together. It could have also been called a biological drive reduction, where you would consider both the homeostatic drive and the incentive pull as both parts of the same system. And so we could use the example of food being an incentive specifically because it's helping reduce your hunger. So you are being pulled towards eating because you want to do that thing because it's good, that it reduces your hunger. So you're pushed by the idea of reducing your hunger, but pulled by doing this act will be a good thing because it's reducing our hunger. So they're very closely intertwined. Modern incentive theory doesn't really go with both push and pull. This is why we're considering drive theory to actually be separate and unique from our incentive theory. So modern incentive theory focuses on the pull side, and usually a pull of some kind of external stimulus. And this pull should be able to happen even in the absence of a biological need. So we had just talked about you want to eat something because it's going to reduce your hunger. That's that biological need when you are hungry. But you can also see an incentive pull when there isn't that biological need, which is why we're considering them separately. But think about having Thanksgiving dinner, and you've eaten your fill, you've had some of everything on the table, you are stuffed to the brim, but then a friend comes out and offers you dessert. There are pies in the kitchen, and you don't need any more food, you don't have a biological need to eat, but man, do you want some pie. So you want that dessert, you are being pulled towards that dessert because the taste and the texture and all of that is something good and you want it. You are incentivized by the flavor of the thing that you could then eat. And so different stimuli, different things, whether it be a pie or a chocolate cake or lima beans or whatever. Clearly I'm hungry, but food's a good example for this. Different stimuli will have a different incentive value. So I am definitely a sweets person, so I would go nuts for a chocolate cake, but if you offered me, I don't know, what's a non-dessert food? Go with the lima beans. I could take them or leave them. So I would assign a much higher value to chocolate cake because I really, really want it, but I wouldn't have a very high value to lima beans. That would get a much lower value because I don't want it as much. And so you can start understanding how strongly people are being pulled towards certain behaviors based on how much they value the thing that they get out of doing the behavior. So they've actually used this particular mindset to try and understand drug abuse, where the people who are becoming addicted to drugs, they don't necessarily want to do the action. They don't want to be doing drugs, but the incentive is the feeling that they get after they've done the drugs. And so that is such a strong pull that it can make people continue to do this behavior even though they know that it's not the right thing and they don't really want to be doing it. So it can be a really strong incentive if there is a high value to the thing that you get. And so now we're going to start working a little bit more into incentive as well as expectancy. So we've already established that people are going to respond differently to the same incentive. I am going to go nuts for chocolate cake, but I have a friend who isn't a huge fan of chocolate. So if our reward is a chocolate cake, I might be highly motivated, but she wouldn't really care too much. And a lot of this is going to start sounding very similar to what we talked about with classical conditioning, where these are stimuli that are motivating us to produce a behavioral response, more or less. And we should also establish the fact that our expectancy theories, once we bring in this part, incentive is okay without assuming cognition, but as soon as you get into expectancy, as we'll see on the next slide, you have to start employing a cognitive perspective. And that means that you have to assume cognition. And that's just sort of the nature of expecting something. We have to have this knowledge that we will get something in the future. And we've kind of talked about this a little bit throughout the class, but there's a lot of controversy around the idea of a theory of mind or having an internal consciousness, where most people will agree that humans have a theory of mind and are conscious of the consequences of their behavior. We can expect to get a cake after doing a task if we're told that we'll get a cake for doing a task. But when it gets into other animal species, it gets a little bit fuzzy because not everyone wants to agree that other species can have a cognitive assessment of a situation. Even when we talked about black-capped chickadees learning to do a task, and if they do the task, they get food, we haven't really said that the chickadees learn to expect that food reward for doing the behavior. But when we get into expectancy theory, that's exactly what we have to start talking about, is expecting a certain outcome for doing a behavior. And that's why we have to bring in this cognitive perspective. And so when we talk about an expectancy theory, of course, there are always different names that can be applied, but the most common one other than expectancy theory is to see it called expectancy by value theory. And that's because our expectations are going to have sort of multiple facets to them. So our goal-directed behaviors are going to be driven by the strength of the expectation that the behavior will lead to a goal. How sure are we that we're actually going to get a cake for doing this task if we were told to get this cake? And then the second thing that's directing our behavior is the value that that person places on a goal. And that's sometimes called an incentive value. So how much do I value a cake versus my friend who doesn't like cake? And so we can look at a very primitive equation. I don't make anybody do calculations on this. I just want you to think about it in abstract terms. But our strength of motivation is going to be proportional to how certain we are that we're getting that reward, that expectancy, times the incentive value. So how much we value getting that goal. And so to make sense of it, I actually have an example that we can walk through. And so we'll leave the equation at the bottom of the page, but we're going to walk through a theoretical situation. And so we're going to talk about 3 different students who have different expectancies and different incentive values when we start talking about getting good grades in a class. And so the first thing is we're going to start with James. And he has the expectancy that if he studies really hard, he's fairly certain that he can get an A. So he has high expectancy. He knows that if he works on this class, he's going to get the good grade. For his incentive value, he thinks, yeah, it would be a great idea. I would like to have a good grade. So he has a high incentive value. He really wants this good grade. And so because his expectancy is high, he knows that he can get that good grade, and his value of getting a grade is high, then his behavior, his motivation is also high. He's going to work really hard to accomplish this task. So for our next person, we're going to look at Lenora. And so the same as James, she still has a high expectancy. So she assumes that if she studies really hard for this class, she can get an A, no problem. But here's where she differs. So her incentive value is not that high. It's low incentive. So her idea is an A would be okay, but I don't really need it. Maybe it's a class that doesn't matter for her degree. Maybe it's something she's just taking for interest's sake, but she doesn't value getting a good grade for this class. So even though her expectancy is high, she knows that she could get a good grade if she studied. She doesn't care enough about getting a good grade to want to study. And so her motivation then is moderate. It's not really good. It's not really bad. Meh. So she doesn't really work hard because she doesn't care enough to work hard. And then our last example, we have Harrison. Poor Harrison. So Harrison has a low expectancy. He thinks that even if he studied really hard, there's no way he could get an A. So he has a low expectancy of getting a good grade. Despite that, he would put a high incentive value on an A. He would love to get an A. It would be fantastic, but he doesn't think that studying is going to get him an A. And so because he doesn't expect the effort of studying to be worth it, he ends up having the same outcome as Lenora did, where he doesn't work hard, because why bother? No expectancy. And so this is the vague interpretation of this equation. And like if you do expectancy theory research, you would actually have numbers that you can calculate for motivation and expectancy and your incentive values, and you can calculate this out. But again, that's more than what we need for this class. I just like the idea that, you know, if you have a high expectancy and a high incentive value, then your motivation is high. And then if you have either expectancy or incentive value, if one's high and the other's low, then your motivation is lower. That's as far into it as we need to get. And for the last part of our motivation in terms of incentive and expectations, when these cognitive theorists start talking about types of motivation, we have two broad categories. The first is intrinsic motivation. In meaning internal, trinsic meaning that it's driven internally. But our intrinsic motivation means that you're performing an activity for its own sake. So maybe you're taking a class not because it counts towards your degree or program or anything like that. Maybe you're taking a class just because it's a really cool class. I ended up doing that in my undergrad degree. I took an astronomy class, not because I needed an astronomy course, but because I found astronomy really cool. So I was intrinsically motivated in that class because I found it really interesting and I wanted to learn about it for my own sake. The opposite, our second category, is extrinsic motivation, so externally motivated. So you're performing an activity to obtain external reward or to avoid punishment. So you're being motivated by some kind of reward or punishment system, which should again make you think back to our classical conditioning and what's the other one? Classical and operant conditioning. I know it's been a long day when I forget the type of research that I have done myself. But for extrinsic motivation, an example would be you clean your room because when you finish cleaning your room, then you can go and eat cake because I really want cake. Or you clean your room so that your parents don't get mad at you for having not cleaned your room. So if the motivation is to get something or to avoid something, it's extrinsically or externally motivated. But if you're doing it because you want to do it, then it's intrinsic motivation.